content is for educational purposes only, drawing from our professional and educational experiences and opinions. Please use this information at your own personal or professional discretion. We are not liable for anything you do with this information.
Good evening. Welcome to Ask the Lady Electrical Inspector podcast. I am your host, Tabatha L. Tonight, we have a special guest who will help us explore the world of AC installations and why some of them don't pass inspections. Our goal is to make sure you understand these inspections better so that your installation meet all the necessary standards. We will discuss common mistakes that people often overlook. Stay tuned as they will introduce themselves shortly. Our discussion will focus on why some AC air conditioning installations do not pass the electrical or mechanical inspections. As inspectors, our job is to make sure that all air conditioning systems, whether new or existing, follow the rules and regulations set by local authorities, electrical and mechanical codes. It's important that these systems are safe to use and don't pose any dangers. Join us for a friendly and informative chat designed to make these complex topics easier to understand. Now, let's give a warm welcome to our guest in the studio. Rob, the floor is yours.
Well, thanks for having me, Tabatha. It's nice to join your podcast. As you said, my name is Rob Vandevoort. I've been a mechanical inspector for nearly 10 years. I've got 22 years of experience in the HVAC trade, 12 of them as a installer across 3 different states, Southern Illinois, Oklahoma, and Arizona, as a journeyman installer. And I currently hold certifications with ICC as a commercial mechanical inspector, fuel gas code inspector, and a level 1 fire code inspector. I don't typically use that in my day-to-day basis, but it's just an extra feather in my cap. A fun fact about myself, I grew up without central air or any kind of a window air conditioner until I was 16 years old, which is probably the reason why I had such an interest in the industry. Thank you for having me on your podcast, Tabatha.
Thank you, Rob. I'm looking forward to an insightful discussion ahead. In this episode, we will look at the main reasons why air conditioning installations sometimes fail electrical inspections and mechanical inspections for homes and businesses. Here are some of the things we will cover. A, the authority having jurisdiction policies and seismic requirements. The National Electrical Code requirements. The manufacturer's instructions. Disconnecting means locations. Branch circuit requirements. Branch circuit minimum and maximum overcurrent protection rating. Protection against physical damage. Service receptacles, working clearances, access for components. Also, industry safety standards, nameplate ratings, and good housekeeping. We will make sure you have a good grasp of what's needed to ensure a successful air conditioning installation. Rob, do you have any thoughts or comments you would like to share before we begin?
I'm just looking forward to, a good conversation to pick my brain and see how I can contribute to your show. So let's get it going.
Yes, thank you. I'll start with the authority having jurisdiction policy pertaining to the location of disconnects. Under the authority having jurisdiction, Electrical Code 1102 and the National Electrical Code pursuant to Article 90.4, the following interpretation of Article 440.14 of the National Electrical Code shall apply within the electrical code enforcement jurisdiction of the authority and municipalities. The subject, the location of disconnecting means for air conditioning and refrigeration equipment. The purpose of this to clarify the disconnecting means for air conditioning and refrigeration equipment shall be located. The code, the disconnecting means, shall be located within sight and readily accessible from the air conditioning or refrigeration equipment. The disconnecting means shall be permitted to be installed on or within the air conditioning unit or refrigeration equipment. The disconnecting means shall not be located on panels that are designed to allow access to the air conditioning and refrigeration equipment or obscure the equipment nameplate. The field application. The consideration must be given to the personnel that service the air conditioning equipment. The language of the code makes the intent obvious, and that is the required disconnect or what it really is for a safety switch for service personnel to be readily accessible. The next thing we're going to talk about is the seismic requirements for the AC equipment. Seismic requirements are vital for the installation of air-conditioned AC equipment, along with obtaining the necessary permits for seismic for electrical equipment as mandated by the local authority having jurisdiction. If you need more information on these requirements and you are within my jurisdiction, please feel free to reach out to my work phone or my work email. Do you have any thoughts on the seismic for mechanical inspections, Rob?
Yeah, I mean, at least in my jurisdiction, we're on the New Madrid Fault, so it's pretty much anything over 400 pounds, located 4 foot above grade. A engineer of record needs to specifically design how this system's going to stay in place, and on a day-to-day basis, I just have to go out and make sure that the installing contractors are following the approved plans. It saves me a lot of headaches because I don't have to understand the math. I like to, but at the end of the day, just complete the work per the drawings and everything goes quickly. If you're having troubles, just get in front of it before I show up. It's all about keeping it in place for seismic so that it doesn't come down and injure anybody below. So
that's great information. Thank you for that. The National Electrical Code requirements and manufacturer's instructions. It is essential to adhere to the National Electrical Code requirements and the manufacturer's instruction for proper installation of electrical equipment at job sites. All electrical products must meet the minimum National Electrical Code standards to ensure safety and compliance. Specifically, Article 110.3 A, B, and C and 314.27 highlights the importance of accessibility to the wiring and installation, such as condensing units in hotels and dormitories, as well as HVAC equipment with flexible cords placed above the ceilings. Article 110.21 Markings. Regarding markings guidelines, Article 110.21 emphasizes the significance of manufacturers' markings on electrical equipment. These markings, including the manufacturer's name and relevant ratings such as voltage and current, helps identify the responsible organization for the product, ensuring clarity and compliance with the code. Additionally, Article 440.3C categorizes AC units as appliances. subjecting them to the regulations outlined in Article 422. These provisions are critical for the proper functioning and safety of AC units, highlighting the importance of following the specific guidelines for appliance installation. Disconnecting means where the air condition or heat pump compressor unit consists of a pneumatic refrigerated motor compressor in combination with other loads such as fan motors. The horsepower ratings of the disconnecting means is based on the sum of all current at the rated load condition and locked rotor condition. Keep that thought in mind with the sum. The disconnecting means location. This is something that I have problems with on the majority of my commercial jobs. The location for the disconnecting means Article 414.14. When it comes to the placement of the electrical switch for air conditioning systems, it's important to follow the guidelines set by the National Electrical Code. This disconnect means should be easy to see and reach from the equipment, specifically if needed to be visible and no more than 50 feet away, be readily accessible, that you should be able to quickly for safe operations, and you are not required to use any tool or facing any type of obstructions. It's critical that the disconnect switch does not block any maintenance work or access to parts of the air conditioning units, and it should not cover any parts of the labels. The disconnect switches need to be located next to the air conditioning units. The disconnecting means can be attached or placed nearby the air conditioning unit, but it must be positioned so that it does not make it difficult to service the unit, regardless of whether the unit is outside or in a crawl space or on a roof. It's essential that the disconnect switch, can be easily seen and reached. It has to be within reach. Not easily seen, it has to be within reach. In some situations, the switch may be installed right next to the air conditioner for convenience if there is the correct safety space around that area. When fixing or servicing equipment, it's very important to have a disconnect switch that is easy to reach. Readily accessible means that you should be able to get to the equipment quickly for operation, maintenance, and inspections without needing any special tools, moving any obstacles, or climbing over anything. This allows for safe and efficient handling of the equipment when it's necessary. There's an important point to consider when it comes to the use of the definitions in Article 100, especially for those who might find the code a bit confusing. Article 440 talks about how easily accessible an AC disconnect should be, and the meaning accessibility is consistent throughout the code, mainly in Chapter 1, without changing any rules in Chapter 4. Article 440 gives specific guidelines about the accessibility requirements for certain types of equipment, which is common practice in these regulations. It's no surprise that the AC disconnect is usually placed right next to the equipment control. For example, in homes, when you have a walkout basement on a slope hill, you might find the AC unit installed several feet above the ground on metal supports. As a result, the disconnect switch is often installed at a similar height so that it's easy to reach the AC unit itself. This setup follows the rules such as the maximum height of 6 feet 7 inches for a disconnect switch according to Article 440.8a. There's also an exception that allows the disconnect to be installed higher, ensuring it remains accessible from the equipment it's meant to work for. And do not forget to label your disconnects. In the end, the correct placement of the disconnecting means shall follow the regulation and guidelines of the local authority having jurisdiction, that everything operates safely and meets the necessary standards for air conditioning installation. Rob, do you have any input or any ideas about the mechanical requirements for disconnects or the height requirements?
I have so many. You hit on so many good points there. It seems like multiple times a week I'm reaching out to contractors that have new guys in the trade that they're sometimes it's not common sense, but they're just rushed to get the job done and move on to the next one. The amount of times I've had disconnecting means mounted on the air conditioner electrical access panel. Granted, the whip is long enough that once you take the door panel off, you're laying a hot fusible disconnect on the side of the roof just to get to the contactors and other controls inside. So those are always a red flag for me that I have them come back and fix. Multifamily buildings and even residential properties that have multiple central air systems, I absolutely make them label them in whatever fashion is suitable for the building. They can call it, master bedroom, basement, first floor, A, B, 1, 2. It doesn't matter. Ultimately, it's to keep the next guy on the job or gal safe from not knowing which circuit they're on. It adds time to your service tickets, to your replacement jobs, and it's not needed. The code is there for us. It's, at least in the mechanical code, it's very clear that, and it's pretty broad what we inspectors get to do, so it's common sense. But it says area served. You must label the unit with the area that it services when it's located remotely from that location. So if I'm on a commercial rooftop, I'm going to have the suite number, whether it's a 4-digit with a letter at the end or what have you. It's all about convenience and safety for the next person. I typically will find disconnecting means with unused knockouts removed, so those also will need to get plugged for safety and weatherproofing reasons, like you already touched on. So,
okay, that was useful information. Thank you, Rob. So next up is branch circuit requirements. Understanding the electrical requirements for refrigerant motor compressors is essential for ensuring safe and efficient operations. The rated load current, as indicated on the manufacturer's nameplate, serves as the basis for determining the necessary ampacity of the branch circuit conductors and the rating of the electrical equipment. This value, provided by the manufacturer, is crucial for sizing the disconnecting means, the conductors and the controller, and the short circuit and ground fault protection device, and motor overloads. Article 440.4b, 440.35. It's important to note that the field calculations are unnecessary, as the AC unit and heat pump manufacturers already determine the specific minimum and maximum ratings on the equipment. In cases where the protective devices has a lower rating, it must still be capable of handling the starting current. So the problem that I have with the AC units, if it has a minimum of 15 amps and it has a maximum of 40 amps, the math is done for you. You do not have to do any more math. You just meet that requirement with the minimum and the maximum. And size your conductors according to which ampacity you're using. So the calculations are already done for you. Additionally, understanding the information on the HVAC equipment and nameplate is vital, particularly regarding the minimum supply ampacity specified. This value guides the selection of branch circuit conductors, referring to the table 310.15b16. With this information readily available on the equipment nameplate, electricians are relieved from the need to conduct separate calculations. And I just used my own example. I got ahead of myself. 15 amp maximum condensing for hotels and dormitory. This is where I find the minimum for their systems. Some of those smaller systems is 15. The minimum is 15. So if you're in a commercial setting and you have the minimum is 15, and that's the maximum or the minimum, you can't install a 20 amp. You have to do it according to the nameplate. Rob, do you have any input?
I think this is the most highly noted item that I call contractors about, in all honesty. I have no better explanation on why this is so prevalent other than energy standards tend to change the goalpost. The old equipment that's 15, 20 years old, it wasn't an energy hog, but it definitely used more than what the new equipment out of the box is. So if I'm not having my contractors resize this maximum over current, I'm doing a disservice to the customer, to the end user, because the first time it gets dirty and it pulls more amperage to compensate for that resistance, they're looking at a new compressor replacement instead of just a service call for a clean and check. And that's completely overlooking any of the fire hazard issues, because we're not talking about overloading your conductor. The weakest point in this conversation is the new equipment, because it has a different standard than what you're replacing it with. So yeah, no, you nailed it right on the head. The only kind of outlier that I've seen, a handful, and it is such a minor amount of time, is pay attention if you have a room addition on a residential property. Sometimes they will like to reuse the wire that's already there, but if you're adding square footage, sometimes you're adding additional tonnage to cover that window glazing and the additional heat load. So you might be stretching your branch circuit beyond its capabilities. And I've had a handful that I've had to tell them, this will not carry the load. It will trip the first hot day of the summer. And ultimately, I point to that manufacturer label 9 out of 10 times. It does all of the heavy lifting for me.
Absolutely. Absolutely. We'll move on with understanding HAV equipment labels. The labels on heating, ventilation, and air conditioning equipment provides important information, as we just stated. One key detail is the minimum and the maximum. This means you don't have to do the extra calculation, as we have mentioned. Please. It's done for you. This is one important change, is that the circuit breakers for the HVAC systems no longer need a special label called HACR. As of the 2005 National Electrical Code, now listed circuit breakers are assumed to meet the necessary standards without the label. However, it's still very important to pay attention to the instructions on the label to ensure everything will work together. Changing from the specified fuse to a circuit breaker can create safety issues and could void the manufacturer's warranty. Most manufacturers will suggest whether to use a fuse or circuit breakers. So always check the label details carefully. understanding this information helps your HVAC system run smoothly, safely, and efficiently. Protection against physical damage. This is an issue in the commercial job sets where you have a flat roof. If your flat roof, the authority having jurisdiction mandates that you use rigid or threaded pipe. It can be IMC if it's for an extended distance. You're not allowed to use LFMC for extended distance because it's subject to physical damage. So that's something that is a major concern as well. Never run your rooftop unit, branch circuits, and feeder cables in seal type. And we call it LFMC, N, non-metallic. So that will be a huge issue because walking on a flat roof is subject to physical damage. And that's how the authority having jurisdiction look at that point of view. The rooftop units are not secured. The blocks are not, they're not anchored on the roof. So they can easily be kicked around. And most of the wood blocks on the roof units are not attached nor treated for the weather either. So it can cause corrosion, and that's just something that I just want people to pay attention to, the physical damage of the raceways on the roof. Do you do many of those in your area, Rob?
I
Many
do.
rooftop
And
units?
yes, I do. And yeah, to your point, you are right. Most of the wood, it's the cheapest that they could buy to get the job completed on time. And they tend to try to reuse it beyond its normal expected lifespan. And I've definitely seen them try to use your liquid tight, non-metallic conduit in longer lengths than what they should. So no, you were hitting on all the right points of stuff that I don't scratch my head, but I definitely wonder why they stopped asking questions themselves as far as, can I do this? Is this proper? What is the correct way that this should be done? Yeah, no, you absolutely nailed it. Yeah, deteriorated wood, things that aren't supported, they're just not going to hold up for the next system's lifespan, so to speak. So,
Gotcha. Thank you, Rob. So the next thing up is, we don't think about it often, but they are refrigerated walk-in coolers. That's a refrigerated system. Disconnect switches must be located inside the walk-in cooler. And the walk-in cooler, that disconnect switch, or if you have an attachment plug, that's a means of disconnect, has to be in a weatherproof box. Cannot be in a 1900 box. 1900 box is not weatherproof. The disconnect means that article is 314.15 for switches and weatherproof boxes for exposed, if it's exposed to moisture. So the service receptacle, that's another issue that is had on these commercial jobs on the roof. People who work on air conditioning maintenance often use portable electrical tools that needs power. According to the safety regulation, there should be a outlet receptacle within 25 feet from an air conditioned equipment. This outlet must be easy to reach and protected from electrical shocks, following the rules of the outdoor requirements. Some manufacturers have combined the power outlet and the devices used to disconnect the equipment into one product. It's important that the power outlet and the air conditioning compressors are separate circuits. The outlet should also be weatherproof and resistant, equipped with shock protection, and have a sturdy cover, a bubble cover that keeps out the moisture. Additionally, manufacturers usually suggest a minimum height for installation to avoid problems with snow and water getting in. Ensuring that this equipment is safe and functional is critical for creating a secure and effective working environment for those in the maintenance field. Working clearance. When it comes to working with electrical equipment, especially those that handle up to 1,000 volts like air conditioning units, it's very important to have enough working space around them. This space is necessary for professionals to safely check, adjust, or fix the equipment while it's still on. According to the guidelines, the areas needed for this kind of work should be easily accessible depending on how the equipment is set up. For example, a service worker often needs to look at a HVAC heating and cooling system while they are still running. Now, I have the problem with the HVAC, the air conditioning units at homes or businesses. You cannot block a meter or any equipment with the air condition. You cannot obstruct. You cannot climb over. So the AC unit and the disconnect needs to be next to each other and have plenty of working clearance. Because as stated, sometimes you need to work on those units hot. Therefore, it's crucial to ensure that there is safe and easy access to the control parts of these units. The minimum space required for safety is 30 inches wide, 36 inches deep. Making sure that this space is available during installation is key to keeping everyone safe. Also, there should be enough room in front of any panel that can be removed to reach the live parts of the air conditioning unit for testing and maintenance. Workers should be able to reach the panels easily without stretching or climbing onto the unit, which makes it for a safe working environment. Last, it's vital to keep the area in front of the air conditioner clean of any obstructions. This ensures that the service professionals can assess the equipment easily and comply with the safety rules. Rob, do you have any thoughts on that?
I do. I have one thought and then one question I guess I would like to ask you because sometimes I don't know necessarily how the sausage gets made, so to speak. But yes, I definitely see the air conditioner set in front of the electrical meters residentially from time to time. And it's usually the same comment from the owners and the contractors, which is, well, this is where it was before, so shouldn't it be allowed to go back? And the simple answer is no, because the end goal is to try to make things as safe as you can while you're there and in that moment. And they never offer up a good reason that's better than we just didn't think about it. So I definitely always make them do that, and usually one mistake is enough, and that curbs any kind of mistakes and oversights for the next project. But you did say something that kind of made my brain perk up a little bit as far as the service receptacles on the rooftop unit, because I definitely see those come either field installed or from the manufacturer. And I guess I didn't realize when installed from the manufacturer that they would have a separate power supply. I guess I always assumed that they came off of one of the legs from, per se, a three-phase system, but you're saying it's actually a dedicated circuit for that outlet.
Yes, they actually bring it up through the pitch pocket through there to for that separate circuit because that's required for it to be separate.
Well, I'll have to keep an eye out for an extra piece of conduit or liquid type coming up through my curbs next time, because as long as it's there and it's got juice on it and it's grounded, good to go, because I trust my electrical inspectors are doing that for me. So
yes, because that's a part of our requirements. Normally, with the new systems, they are separated because you have your with the larger systems, the 480, you will have your sections in that equipment that's only 480. So it's separated. So you have to bring up the circuits anyway to feed the unit.
Good to know.
You have to bring up the separate circuits. That's
Good to
required.
know. Perfect.
Okay, so let's just go with that a little bit more details on the accessibility of the components. And I mentioned that because we have to keep in mind when you are in a commercial building, we spoke earlier of the AC equipment being readily accessible. So if you have acoustical ceilings and decorative ceilings that require you to use a special tool to remove the ceiling, it's not readily accessible. So that's an issue that has come up on several of the commercial jobs, and that's something that needs to be taken into consideration with the locations if you're going to put it in that type of ceiling. It should be in a drop ceiling or drywall ceiling with an access panel, not the type of ceiling where you need to take a tool, a slate ceiling, and remove the panels to get there. It's not readily accessible.
Yeah, I had one of those as well myself where I made them demonstrate, or maybe it was my electrical inspector, they made them demonstrate that a single person could take down the slats, ensuring that it was, to your point, readily accessible. Because if it requires two people, that's essentially a tool, a special situation. So,
Yeah, that sounds like something I would do. Alrighty.
didn't name
Moving
names.
on. Yes. Yes. So as we move forward, for servicing any electrical equipment, an access panel is required. This panel should be framed in before the ceiling is covered. Here are some issues we are facing. And I just spoke of the wood slate panels, and we need to make sure that the electrical equipment, including the heating and condensating pumps. Okay, I know where I'm going with that. The accessibility, I spoke of the one in the ceiling, but also when you're doing dormitory rooms in colleges and hotel suites, the condensing units in those rooms, depending on the layout and the framing of the wall, the components are sometimes not accessible without taking out that entire unit. And that is a problem. You should not have to remove the whole unit. It has to be readily accessible with the access panel or quickly to be able to look at for maintenance or inspections. So if you have to take the whole unit out, think about that design. Moving on. So now I'm just going to give you a few industry safety standards. Safety standards information for overcare and protection requirement for air conditioning equipment is UL 1995. Heating and cooling equipment UL 484. Room air conditioning product safety standard requirements. Ensuring when air conditioned units can be installed. Installing an air conditioned equipment safely is very important. There are special rules that must be followed to make sure everything works properly, such as following those guidelines, the National Electrical Code, the mechanical codes. When it comes to the air condition, there are safety standards that must be met. As I mentioned, Rob, do you know of any mechanical safety inspections, like any mechanical safety standards?
Pertaining residential, commercial, I mean, I could think of a few, especially condensate pump wise.
Okay, just give us one of those.
Sure. Obviously, if you're using a condensate pump, gravity's not going to get the water out from the coil to a point of termination. And when those are located anywhere that a overflow or a fault of the pump could occur, you are supposed to have a secondary way to prevent the unit from producing more condensation, to notify the owner of that. So on your Little Giant as a name brand, you'll have a couple of little pigtail wires, 18 gauges coming out. Those are supposed to be wired in series with your cooling legs so that it will physically or electrically prevent the air conditioner from producing more condensation, which could damage ceilings, walls, flooring, permanent construction from a from a condensate backup. So that would definitely be the one that comes to mind first.
That's good to know. I didn't know that. Huh. That's a more mechanical, huh?
It is, and most of them, they're all going to have a UL listing showing that
Mm-hmm.
they actually meet those standards. But yeah, there's 4 or 5 provisions as far as where and how they can be installed. So check with your local AHJ and find out if their ordinance supersedes or omits any of them from the published code that they might have adopted, because that's where you
Thank
could be
you, Rob.
starting with anything is the
Mm.
ordinance. That's the first stop.
Thank you. That's useful information. Now we'll move on to the safety labels. Every air conditioning unit has a label that states what type of electrical safety device it needs and what size is allowed. It's essential to follow these instructions, especially if you're adding a new air conditioner to a home that already has an existing electrical setup. By sticking to these safety guidelines and following the manufacturer's instructions, you can ensure that your air conditioning system is installed properly and runs safely. Good housekeeping. Keeping your job tidy is important for safety and comfort. It's essential to clean up after yourself to create a safe and pleasant environment. Many homeowners have emphasized to me while I'm doing inspections that they wish that the electricians were more dependable and would value cleanliness more. This means cleaning away your trash, managing leftover material, and ensuring everything related to electrical work is organized and secured. By practicing good housekeeping, both inside and outside, you can enjoy a safer and more welcoming area. During our discussion tonight, we shared some important tips on how to check air conditioning units. We stress the importance of following safety rules and local laws to keep both homeowners and business owners safe. Regularly checking the electrical and mechanical parts of your AC system is essential to avoid problems like electrical malfunctions or fires. It's best to hire a licensed electrical or mechanical and professional to repair anything you may need. Working on electrical or mechanical projects, whether starting new ones or fixing existing setups, can be tricky. My podcast aims to tackle these challenges head on. Our goal is to solve any electrical issues quickly so that everything can keep moving smoothly. Good communication between the electrical contractor and the general contractor is really important. It's essential that everyone is on the same page about the local regulation and safety practice. Stay informed, prioritize safety, and encourage those important practices among your friends and family. I would like to extend a heartfelt thank you to our special guest, Robert, for sharing his valuable knowledge and information for tonight's podcast. Would you like to have any final words, Rob?
Just a big thank you to you. I appreciate the offer to come join you on your podcast and just try to get the word of safety out there to people to, go home safe and healthy every night and wake up to their families and loved ones. So thank you again, Tabatha.
Thank you, Rob. And finally, I want to thank all the listeners of Ask the Lady Electrical Inspector podcast. I will be taking a short break due to health reasons, but I plan to return as soon as I can. Your support and thoughts mean a lot to me. Stay tuned for updates on the next episode by following me on social media. You can visit me on YouTube where I post short videos. Also, you can learn more about the best practices to follow and what to avoid dealing with electrical systems. If you're interested in learning more about electrical standards, check out the Best Electrical Podcast feedspot.com. Feel free to reach out on social media with any questions, comments, or topic ideas. You can find me on Facebook, Instagram, YouTube under the name Ask the Lady Electrical Inspector. Let's work together to keep our electrical systems safe and up to code. Thank you for your time and have a great night.